Today we will be exploring the Pythagorean theorem. The equation for the Pythagorean theorem is a squared plus b squared equals c squared. This theorem is specifically for right triangles. Now you're probably wondering, what is a, b, and c in this equation? Well, this is for a right triangle, as shown here. This side will be a, this side will be b, and this side will be c. So today we're going to use this to solve a few problems. Our first problem is the diagram shown here. In this, we are looking for c. So, as we previously mentioned, the equation is a squared plus b squared equals c squared. If we plug in the values here, we're going to see that 3 squared plus 4 squared equals c squared. And then 3 squared is just 9, 4 squared is 16, and then this will equal c squared. 9 plus 16 is 25. 25 equals c squared. The square root of 25 is just 5. So our answer here would be 5 units. Now let's go on and look at a harder example. In this problem shown here, we are also looking for the c, or the hypotenuse. Now, again, our equation, our good old friend, a squared plus b squared equals c squared. 4 squared plus 5 squared is equal to c squared. Now, 4 squared is just simply 16, and then 5 squared is just 25. This will equal c squared. If we add those two values together, you get a value of 41. So c squared will equal 41. Now, if we take the square root of both sides, we will get that c equals the square root of 41. Now, the answer doesn't always have to be a whole number. It can also be a square root. Next, in this example shown here, we are looking and trying to find for a. So again, our formula, a squared plus b squared equals c squared. You should always have this memorized because it might be on a test or quiz, and then the teacher most likely won't give it to you. So, in this problem, we know what b is, we also know what c is, but we don't know what a is. A is our unknown value. So, we just also plug in values. A squared plus b squared, which is 12. So 12 squared equals c squared, or 13 squared. Now, 12 squared is 144, and 13 squared is 169. If we subtract those, we will get a squared equals 25. And then if we take the square root of both sides, we will find that a is simply just 5. Now we're going to look at some common Pythagorean triples. Now here are a few types of common triples. So we have triples are just ABC pairs. So a common one is 3, 4, and 5, which we discovered in a previous problem. Another one is 5, 12, and 13. Now triples come useful when you're out of time on a test or quiz, and then your teacher still gives you a lot of problems that you have to quickly solve. Triples can come in extremely useful. Now, our last pair, I want you to notice what's similar with this before I tell you. I'm just going to write it down. 6, 8, 10. Did you guys notice it? If you look here, 3 and 6, these are multiplied by 2. 4 and 8 multiplied by 2. 5 and 10 multiplied by 2. So if we use this principle, we have unlimited triples. This can be extremely useful, especially if you're a quick mental math person. Thank you so much for watching my videos. Please consider liking and subscribing. Thank you.